Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So in this problem, we are talking about a skier, and like we do for most problems, let's start by writing down which variables we know. It tells us that the skier starts from rest, meaning that initial velocity is 0 meters per second, and she skis up to a final speed of 8 meters per second. And in total, it takes her 5 seconds to get up to speed. Now, we have three numbers we know, v, v naught, and t. Part A is asking us to find the acceleration of the skier during this period of time. So since we do not know what x is, and we also aren't trying to find x yet, we want to use the equation that doesn't have an x in it, which is that first equation, v equals v naught plus at. I'm going to plug my numbers in here. So we have 8 equals 0 plus 5 times your acceleration. Then to finish this up, I just divide both sides by 5, and we end up with an acceleration of 8 divided by 5, or 1.6 meters per second squared. Okay, then part B wants to find the distance that this skier travels during this period of time. And because we already know A from part A, we could really use almost any of these equations that has an x in it. I'm going to be using this equation because it doesn't use that acceleration. And the reason I'm going to do this is if we made a mistake and our A value is incorrect, then that mistake would not carry over to part B. Anytime you can avoid it, you don't want to use the same piece of information you solved for previously to solve a new problem. If you got it right, it won't matter, but you're not always going to get 100% of your problems correct. So x equals 1/2 of our final velocity of 8 plus the initial of 0 multiplied by the time of 5. And we put this into a calculator, we end up with 20 meters for the distance this skier travels during this period of time.